So now we're going to solve this problem. A 220 volt shunt generator has an armature resistance of 0.02 ohms and a shunt resistance of 44 ohms at rated load. The driving engine develops 62.25 horsepower. If the iron and friction losses amount up to 1600 watts, how much is the current delivered to the load at rated condition? So first, in this problem, we're going to draw the circuit. So we have the power supply. We have the inductor. Oh, resistor rather. And then we have the current A. We have the current in shunt. The resistor in shunt. And we have the output current and the output voltage. So now we have the our circuit. So now let's solve the problem. So first, we have a given of 62.25 horsepower. So we need to convert this one into power into watts. So we simply multiply this into 746. So HP times 46. So we have the power input of 0.5 watts. And now we're going to solve the current in shunt. So we have we're going to use VL because it is parallel connection. So we have a condition of VL equals to V. The voltage in the load equals to the voltage in the shunt connection. So we have equals 5 amperes. So we have now current in the shunt series. So we have the equation of so we have this one. So in getting I in the armature current, so we have this equation. IA equals current in the load plus the current in the shunt. So in the current in the shunt we have 5 amperes. This will be our equation 1. Let's go get some extra sheet of paper. So now we're going to next equation is the power input equation. So we have the PL plus the PA plus the power stray. So we have the power input. So let's expand this one. This one will be equal to voltage times the current and this one will be current squared times the resistance, and this one will be the voltage times the current. And we have, now we're going to use the numbers. We're substituting all the numbers are available in our problem. So we have the power input of we solved earlier, equals to VL 220, copy the IL, plus IA. We have IA equals to IL plus 5 amperes. So we have IA IL plus 5 squared times the RA. We have an RA of 0.02 plus this one. We have 220 times 5 plus the power stray is 1,600. It was stated in the problem earlier. So we're going to simplify all the numbers. So we get the 4 copy. We have squared plus 0.2 plus 0.5, transpose this one. So we have so we're going to simplify this given. We divided by 0.2. So we have IL plus IL minus equals to 0. So we have this one. Can you notice we have the quadratic equation? So we're going to use the quadratic formula of this one. So quadratic formula will be so we have a quadratic formula of over 2a. So substitute this given to this formula. So we have IL equals to, we have a B of negative 11,010 plus minus square root of 11,010 squared minus 4 times the A, which is 1, times DC, which is 2 1 0 all over the 2 times the AU. So we have answer of plus minus since we have a two answer positive and negative, since this is a current, we're going to use the positive result, so we're going to use 195 amperes. So the current of the load is 195 amperes. So our problem is solved. Thank you.